G'day everybody and welcome back to the channel. I am going to get started on assembling these little boards that you see right here. But before I do that, I'm actually going to do that in a separate video. I wanted to take the time to do a video just on this one subject of the transformers. I just want to go over it and see if I've missed anything. But I think it's an interesting subject and it's something, you know, to catch on camera. So I'm going to get this of a green mat and move all this stuff out of here, and we will look at these. Well, I only need one. Actually no, I need both of them. So I've been thinking about this, and I did have a go at this the other day, but I did it, you know, in a bit of a hurry. These are heavy, they're freaking good transformers. The primaries, oh, I've got the wrong side facing you guys, sorry. There we go. The primaries, as you all know, we have a 1.3 ohm winding on each side. However, one side has got an extra tap here, and you've got 1 ohm between here and here, and 0.3 ohms between here and here. Now, as we know, if we wire this up, this is what doesn't make sense, and this is what got me thinking, right? Originally, I thought that they had just had this side hooked up as 1 ohm, and this side hooked up as 1.3, and that's how they were getting the 47 volts off each rail, and enough for the 15 volt fan circuit. However, two things that I can't get my head around with that: the linearity issue of, you know, one side having less voltage and current on it than the other. The other thing is, when I did that, although it brought the voltage up, it still didn't produce enough power to run 2 fans, which means the core did not have enough flux density. Or enough flux stored in it, you know what I'm trying to say. The field was too weak and the voltage is sagging too quick under load. Now, I can't say that that's how it was running in the amplifier, so that's got me thinking, did they somehow have the two transformers wired up in a different manner somehow? Is there something I'm missing there? I mean, it's bloody strange. So what I want to do is try some different combinations. I don't think I'm going to have any luck, I'll be honest, but you never know. The first thing I'm going to try is, with still leaving this together, sorry, not together, using the 1 ohm coil. So I got to think about this myself. I want to wire the two transformers up in a few different combinations and see how it affects the output voltage. I really can't wrap my head around this. It just doesn't make sense. I mean, these were the transformers that were in the amp. It was 500 watts a channel, and the thing that, sorry, 500 watts an amp, there was 2 amps in the 1 amp. The thing that shows that there's an issue here the most is the fact that I can't get 15 volt regulated to power a fan, and this, when it was in the amp it came out of, was powering a 15 volt regulator, you know, for a fan circuit. It just doesn't make sense. And as I've said, it doesn't make sense to have 1 ohm here and 1.3 ohms here. So there's got to be something going on that I'm missing. So what I'll do is I'll get some crocodile leads, I'll bring some 240 over here. I'll have a look and see if I can find some documentation, more schematics and stuff about the inside of the amp these came out of, and maybe I'll be able to find the wiring diagram for the AC side. Other than that and experimentation, I don't know what else we can do. Alright, so I've got everything set up here. I've got 2 dim bulbs in the dim bulb, so there's 50 watts. So when you see that light up, that means that we're drawing too much power. I'll just show you something just so that people that aren't too familiar with transformers understand how this works. Yeah. Alright, so if we connect it up correctly, I don't know why I do silly things like holding 2 leads in the same hand. I mean, I am sitting on a chair, but if both the boots spin at the same time, that would not be good, even going through the light globe. So you see, you can't even see the flash. I can, but it's very small. Now, if we change one of the windings and put it out of phase, you see the light lights up straight away. Okay? So it's very easy to see this way if something's wrong, and also not going to get a huge bloody bang, you know, when you wire something up wrong and it tries to pull a crap ton of current. So I'll expose these. Right. So, first things first, I just want to show this. If I wire it up like that, or with the 0.3 ohms off, the light globe's still not lit, okay? It's only going to light if it takes a lot of current, not just a couple of extra milliamps, like 10 milliamps or something like that. All right. So, let's try and put the 2 1 ohm windings. Actually, you know what? Let's try. I really don't think I'm going to have any luck with this, and even if I do, I still don't see it being correct because it's going to be imbalanced. Let's give it a crack anyway. Alright, so in, out of the 1 ohm tap, into the other 1 ohm tap. Maybe I should go into this 1 ohm tap. Okay, well that works. Maybe if I Okay, that works. Let's see what voltage we got on the secondary now. I feel so silly doing this, but it just doesn't make sense. Like there's something I'm missing here, you know? Oh God. Only in Dave's lab do these things happen. Anyone else would just get a bloody normal transformer that works. Oh, I'm on amps, that's freaking hilarious. And I'm on DC. What's going on today? Try again. That's interesting. That's exactly the same as when... Yeah, okay, so there is no difference if you put them in series. The reason I thought there might be a difference is because I have instead of the two windings in series with each other, I have a winding on one core in series with a winding on another core, so it's got a different flux density relative to the winding that's in series with another winding. I don't know if that makes sense or not. Now, I've really tried thinking out the box on this one. I mean, what else am I to do? This doesn't make any sense at all. Don't worry, I can touch this comfortably. I'm completely floating. Yes, this is 240, you know, but because I'm floating, yeah, all good. Man, this has got me scratching my head. I freaking hate it when shit doesn't go to plan. Okay. Talk about an odd one. I think that the other thing I wanted to try, I had all these ideas I came up with when I was lying down in bed, and now I can't think of them. I think I was going to connect the two windings in parallel and then the two parallel windings in series, if that makes sense. So let's try that. But using the whole 1.3 on each side. I'm just trying to think. To hook it up in parallel, it would be like this, wouldn't it? I might get this wrong and have to do this twice. It's all good. It is what it is. It's not like I need to actually sit here and put any actual effort into this because I've got a bloody dim bulb here, so pretty much could do what I want. The worst thing that will happen is a light bulb will light up. So that's there. Oh no, we want them in series with each other. Ah, God. Don't worry, I'll get there. At least that's what I'm telling myself. Correct first go. What do you know? Let's see what voltage we've got. Because this is the only other thing that I can think of. Is having the two in parallel and then the two in series after they're paralleled. I bet you we're going to have bloody 43 volts. I'll be really grateful if we don't. Why do I get... I know why. It's because I'm just so used to putting it on DC. It's just intuitive to me to pick my meter up and go click, click. Wait, you're kidding me. That's it. Oh my God. No way. We don't need the boost transformer. Oh, this is awesome. You know what? Let's just do a quick test. Oh, this is going to be annoying, but it is worth it. It is definitely worth it. I'm going to series up the secondary, not the main secondary, the one that runs the fan circuitry. I know this is dodgy. I've got 240 everywhere, and I'm going to have to bypass the light bulb at some point too. Look, don't do this at home, alright? I'm really comfortable doing this sort of stuff. I do it all the time. I have been playing around with electricity since I was literally a little kid. And when I say a little kid, I'm talking like 6 years old. You know, so as a 33-year-old now, I'm extremely comfortable with it. But at the same time, you don't want to get too comfortable because that's when you can zap yourself too. So, I mean... I'll just go get 2 fans. What I'll do, we don't need all the circuitry. What we just need to do is create the same load that we had, which we can do that quite easily with 2 fans. I'll stick a regulator in here. I'll just go grab another regulator. I've already bent the pins down on that, that's the problem. Actually, let me just get a heatsink too. Just grab this little clip-on heatsink for testing. I'm not worried about, you know, the 100k or whatever of resistance on, it probably drops down to about 15 when you add up the NTC, the 10k resistor and the 2.2k resistor. Say it's 15k of resistance between the rails, you know, 1.2, no, there's about 1 VBA drop the way I've got the transistors done, sorry. Actually, no, there isn't. No, it's in saturation. Yeah, so if I just wire up these fans through the regulator, that will mimic the same load basically, you know, maybe minus a couple of milliamps, but not enough to make a difference. We'll be able to get an idea of if we have enough power here or not, just by running the fan through the 15 volt regulator and checking the voltage. I just got to get a capacitor. Alright, I'll just stick a 47 mic tantalum in the output, and I'll put a 2200 mic electro on the input side because we need that for the ripple. No, I'm not laying this out properly. I mean, this is just for a quick test, it doesn't matter. Unless it was like literally oscillating or something crazy, then that would be a problem, but no, it's not going to do that. Ground. One more wire. Oh, you know what else? I've done it again. I've done it again. I'll go get a bridge rectifier. My bad. Oh, God. Oh, this is great news if I don't need a boost transformer. I really didn't want to have to add a boost transformer. What I'll do is I'll I can't do anything about that. I'm in the middle of uploading a video right now where well, you'll know because it will be uploaded before this one, where I'm going over adding a boost transformer to bring the voltage up on these. Oh well. Just realised this might be off camera. Let me double check the screen. Let me just get this bridge rectifier in the breadboard. Come on. Get in there. Alright. Oh no, we're still on screen. Cool. Alright. We'll bring over our AC. And I'll go get a multimeter. What? Oh, I see. I've done it again. I've wired up the 2 windings in series, in phase with each other. Alright, we just need to bypass it. Wait, what? What's now? What have I done? What have I done? I haven't done anything. That is wired up correct. What? Oh, I see. The fan wires and the regulator are one track over from where they're supposed to be. I was going to say, what the hell? It's got to work. Might not be right, but it's got to at least spin. I was expecting maybe the rail voltage to not be the whole 15 volts with the two fans on here. Like, that's what we're doing this test for, but nothing. All right, let's try this again. Ah, man. Now what? Output going to the fans. No, it's not the capacitor missing. Don't think I'm that silly. I'm just putting it in because it wasn't in. Why is it not working now? Told you it wasn't the capacitor. What? This doesn't make any sense. We definitely have power here. What? Oh, God. You've got to be kidding me. Have I fried this regulator? I think I fried the regulator, guys. Wait, is this back to front? No. I can hear an insane load on that when I connect this. When I say insane load, an insane load for... I thought that was getting hot. No, it's not. Where is my power going? What? Nothing's getting hot either. What the... Yeah, you dope. I'm not going to test the incoming power. Alright, something's seriously up here. Something's taking power. I'm really confused. Must have just been this capacitor charging up. Still doesn't explain why this isn't working. Ah. Goodness. What on earth? Let's take the fans out just in case this is not providing enough current. I can't see it with the size of the spark that it made when I short the... You can hear that. That sounds spicy to me. That's odd. What? That's the regulator. No, something's not right here. Have I got a brand new rectifier that's no good? Something's just not right. Voltage shouldn't come up all slow like that. Oh no, it is staying there. Wait, what? Is this about to go bang in my face? I don't know what is going on right now. We don't have enough power. That is what's happening. There you go. I'm holding both the fans on the 2200 mic cap straight off the rectifier, no regulator in there. But surely that wouldn't stop the regulator from working. Hold on. 17.6 volts, 15, 16, 17, yeah. We should have 15 volts on the output. What? Oh no. Whoopsie. I'll be back in a sec. That's a 7912. It's a negative 12 volt regulator, and I might have just destroyed it. Alright, I believe this is what I was looking for, a 7815. I'm sure we'll have 15 volts now. 15 volts, almost like it's a miracle. 10 volts with one fan. So that's bullshit. I was so happy, I thought, oh, I've got out of it. I can do this without the extra transformer. Man, this makes absolutely no sense. You're telling me that the amplifier was actually made like this? What, they just had 1.3 ohms on one side and 1 ohm on the other side? I find that so hard to believe. I'm sorry, it just doesn't make sense. You've got uneven rails. Like, I'll leave this off to the side because I'm still going to play around this transformer and we might need that as our test setup again. Oh, goodness. Alright, I'll put the dim bulb back on. What else is there I could really do? Because in order to keep both the sides linear, it's got to have 1.3 ohms on each side, and well, I've tried them in series and parallel now, so there isn't really any other options. I think I'm going to have to run these with a boost transformer. These transformers were literally wrapped for a higher voltage than 240 volts. That makes no sense to me. I don't understand it. Not at all. What country has more than 240? Oddity. I'm going to pause and have a little think about this and do a Google and see if I can find any more schematic sort of information about the amp that these came out of, and see if I can find where they're wired, how they're wired. I'll be back in a sec. Alright, I've had a look online and I couldn't find literally anything about this particular amp. It turns out I've actually got the entire, whatever you want to call it, user manual, schematic, everything. I've got the entire thing and there's nothing in here mentioned. Just specs. See, I'm starting to wonder if they actually... Okay, let me explain something. At 8 ohms, it does 165 watts times 4. That's, 165 times 2 per transformer, 250 times 4, that's 250 times 2 per transformer. Look, to get that sort of voltage is easy, even if this was running 1.3 ohms a side and only had 42 to 43 volts, because rectified, that's going to be around 55 volts, something like that. You only need, what, 33 volts, something like that, at 4 ohms at your output to have 250 watt. At 8 ohms, I don't know, 40 volts, 40 something volts. You know, this would have just been there depending on how much it sagged under load. So what I'm wondering is, did they just have 1 ohm on one side and 1.3 on the other? And, you know, like one winding's got 42.9 volts and the other side's just over 43 or whatever, you know, like, I get it's only a 20 or whatever millivolt difference, but it's not just the voltage difference, it's the current difference and how it sags under load and all the other stuff that you got to take into consideration. That's what makes me uncomfortable about it. The other thing is, who in their right mind would design an amplifier with a fan circuit that has a 15 volt regulator where the input voltage falls below the dropout voltage of the regulator, hence the regulator falls below its output voltage as the fan comes up to full speed? That doesn't make sense. So I am confused. Yeah. And the thing is, the other question I have too is, building a PA amplifier that does 4 ohms, 250 watts a channel, you would use around about a 750 VA transformer. And based on the size, that's what I believe this is. But the other thing I'm wondering is, was this designed to do that with the two 1.3 ohm, you know, the complete winding on each side? I mean, I would assume it would. It just, none of it makes sense, you know what I mean? I've just got so many questions. Anyway, I want to go do my shopping now and then come back and then have another little play around with this and the other one together. I just, you know, I know when something's not right, and something's not right. I'm not saying it's wrong to boost the voltage and run the two 1.3 ohm windings. There's nothing wrong with that. That's perfectly fine. It's just, I feel like I'm missing something at the same time. Yeah. It's an odd one. I really don't know what to say. The only thing that I can say is that I know that I'm onto something, because when you wire it up just normally, you get 43 volts. When you wire up one of these in series with one of these, and the other one in series with one of those, one of these in parallel with one of these in parallel with one of them, and then the two transformers in series, you get 47, 48 volts. Which is the same as when you run 1 ohm on one side and 1.3 on the other. So, you know, it makes me think that there is something going on here. Very, very confusing. That's all I can say. Yeah. It's had me scratching my head for about a day and a half now. Coming up 2 days. And I just can't understand what's going on here. I mean, it's not like you can unsolder this, desolder this, and bridge this in some other combination, because the windings wouldn't be in phase. That can only go together. you know. Um, yeah, it's got me as confused as anything. I mean, there is one other thing I could think of is to... No, actually, that's not going to work. Never mind. I mean, yeah, you could separate this and that and wire it up in a few different ways, like taking the 1 ohm and the 1 ohm and putting them in parallel and putting the 2.3s in series. And, you know, I mean, you could do weird shit like that, but that's obviously not how it goes, you know? Like, this is the weirdest thing I've ever come across. Like I say, why on earth would anyone design a transformer for a higher input voltage than 240? That doesn't make any sort of sense. This is the strangest thing I've ever come across with a transformer. Yeah. The only other thing I could say is what I've already said. Maybe the manufacturer literally made this to run the way it is, underpowered. I just don't understand that though. Like, what? The fan runs off of a 15-volt regulator that doesn't even put out 15 volts sometimes because the transformer can't supply it. It just doesn't seem right at all. And, you know, with the flux density of the core down so much because of the primaries being insufficiently powered, these rails are going to sag a lot more under load, which is a terrible thing for an amplifier. It just doesn't make sense. The more you know about a transformer, the less this makes sense. So leave it in the comments if anyone's got a clue what's going on here, because I sure as hell don't. And, you know, when it comes to transformers like this, I thought I knew literally everything about them, so I don't understand what I'm missing. Maybe I'm not, like I say, and it was just done really crap, but I just have a hard time believing that. And anyway, I mean, at least I've come up with a solution to boost it. It's just an ugly one, having to use a whole extra transformer. I mean, I don't realistically need... Hold on. Oh, I forgot what I was saying. Anyways, yeah. I really forgot what I was saying, eh? Oh, well. So, I hate to say it, but I don't have any more options other than to sit here and scratch my head for another half an hour, and I'm going to have to give up if I don't come up with anything. So, yeah, leave it in the comments if anyone knows. I'd be curious to know. Very curious. Even if you've got an idea what you think's going on, like, yes, the manufacturer was just running them underpowered, whatever you think, leave it down in the comments. I'm curious to know what you think. I've certainly never seen anything like that, and I've certainly not seen a transformer inside an amplifier with a 240 volt plug on it that says 240 volts on the back of it and on the schematic, that has a winding on the primary that's bigger than 240. It just, yeah, it boggles my mind. Alright, I've given up. I've had another think about this, and I forgot to show you when I was here just before my shopping. I was having a look through this, saying I've got the whole manual here, but I didn't show you guys the entire thing. It's just got components, you know, parts list, how to use the thing up the top, other bits of equipment that go with it, and the schematic that we've already looked at. And I'll go back to the schematic again for a quick second just to look at where the transformer is in the schematic. And as you can see, you've got the transformer, the primary winding, a thermal switch, a primary fuse, and then a power switch, mains, capacitor across the switch. There is nothing, there's nothing to it. Just, yeah. Likewise with this. 78015AP, which is not a low dropout part. It's got a dropout voltage of 2 volts. So I just cannot work this out. I'm going to leave the video here. I give up. Yeah. I guess for now, they're just going to have to run boosted off of we'll call it 257 volts roughly. I mean, the 240 is always over 240 here. Actually, is it still these days? I haven't looked at it for a while. Oh, it's not. It's 237. Wow. Okay. When I used to check the power every so often, but I haven't looked at it for a few years. Anyway, so it'd be running about 255 volts. So I guess I either have to put both the amplifiers in one box and, you know, the extra transformer in that box. Excuse me. Or the other option is build the booster transformer into a little box, and basically my two amplifiers will have to plug into that box, and that box will plug into the mains. It's really not a great solution. That's why I'm digging into this as much as I can and hoping that I can come up with a solution. It's just really strange. Anyway, I'm going to leave that here. Thank you for watching. And like I say, if you've got an idea, even a suggestion, leave it in the comment section. Yeah, it's not often you'll find me asking for help, but I'm asking for help this time. I've not come across anything like this. Anyway, thanks for watching, and I'll see you all in the next video.